Hi there. So we're going to do an overview of module 2 where we talked about a VPC and EC2 instance and what they are and what we are going to use them for. So remember we had a couple of simulations and creating a VPC and creating an EC2 instance, and we test it. So remember we have different components of our VPC. So let me just go ahead and create our VPC. And so I'll create a VPC only, so we'll create everything step by step. So we'll call this AWS Cloud MKU. Say DR block. Remember we also talked about this, and this is going to be the number of IP addresses that we assign to our VPC. So I'll do a 24 just to make it simpler, and when we create the subnet I'm going to talk more about CIDR and why it's important. Yeah, so I think we can create the VPC, and here it is. So at the moment we don't have anything inside our VPC. If we check the resource map, then we have our VPC and no resources inside it. So the first thing you do is you create a subnet. After the VPC you create a subnet. So here we have default ones, but we're going to create our own. So we'll create two subnets, a public one and a private one. Yeah, so when you create a subnet, the first thing you have to do is you have to link it to your VPC. So remember, these things are linked. VPC, subnet, route table, internet gateway, they are kind of linked, so you need to understand how to connect them to each other. So in this case we are connecting our subnet to our VPC with that IPv4 CIDR block, and then we'll have public subnet, cloud MKU. Availability zone, we can do US East 1, and then now this is where it gets interesting. So I'm going to open a website here called subnet calculator, because we need to divide our network into two. So we have our VPC. So let me just go here, and when you come to this website, and what I would urge you to do is to calculate. So we have this IP address 1, 2, 3, 4, and then 24. So remember, that is what we put in our what's it called, in our VPC rather. So our IP address, it has 256 hosts. So this is the network that we want to divide. So our VPC has 256 hosts, and we want to divide it into two. The first 128 go to the public subnet, and the other 128 go to the private subnet. So when you come here, if you want to divide, just come here and play around with these numbers. So how you do this is going up. This is just a trick. Going up, so 25 we subdivide it into into 2. So you see we have two possible networks. So these values are the ones that you're going to use for your subnet. So since we want to divide our network into 2, these are the ones we are going to use. If you want to divide it into 4, just go to 26, calculate, and yeah, you guys can do more research on how subnets work and what these numbers are, because this is binary and I don't want to start going into binary, but the ones represent the number of CIDR notations. So in this case these are 26, and that is how you do it in binary, but I won't go into that. So when you want to subdivide your network, so in this case if you wanted 4 subnets, the first subnet will have this ICDR, the second one will have this one, the third one will have this, and the fourth one will have this one, depending on whether it's private or public. So in our case we want to divide it into 2 only, and so like I said, you can use this trick. So 24/24 or /16 is like how I try to start. So if you start at /16, 17 is half, 18 is half, 19 is half. So you go doing that. So I decided to start with 24, which means 24 there are 256 hosts. So if I want to divide this into 2, I just go into the next one, which is 25, and then this is what I'm going to use for my CDR block. So I come back to here, and so for the first one you do 0/20, so this will be /25, since we are dividing this 24 to this. Hope this is making sense, and if you guys don't get it, you can reach out to me. So that's the first one, the first public subnet, and then now we do the same for the private subnet. So we create a private subnet, but we won't use this, so we're just creating this so that I show you how to divide like the CIDR block correctly. So is it cloud-NTU, and then remember the other one we put US East 1A, so the next one is US East 1B. So this is the VPC CIDR block. So for the second one, come back here and check. So if this one goes to from 1 to 126, then you have the broadcast address. So you start at 10.0.0.128/25. So don't forget the /25, since you divided it into half. 28/25, and note that if we do anything else like this, this is funny, this should give us an error, but yeah, 28. You should make sure use the correct CIDR block, and just use this as your resource to calculate your network address. Don't do it manually, or if you're good with binary, you can do that as well. Yeah, so you just need those 2 subnets, and just confirm 128. I think we are good. Create subnet. Yeah, so now we have 2 subnets, one public and one private. So remember, this is not public until an internet gateway is attached to it. And since that's the case, you need to create an internet gateway. So you come on the left, click create internet gateway, cloud internet gateway, and then that's it. There are no other settings over here. So create your internet gateway, and notice that it is the state is detached, so this is not attached to anything. So you need to attach. You see it's even saying here attached to a VPC. So just click attach to VPC and make sure you select your VPC and then attach the internet gateway. That way we'll now be able to have access to the internet when we link our public subnet to it. So now where do you link the public subnet and the internet gateway? In the route table. So you come to the route table and we create a route table, AWS Cloud URTB, and you need to specify your VPC, and let me just call this public cloud MKU route table, and then create route table. So now we have a route table and we have an internet gateway, we have a route table. Now the last thing you need to do is you need to associate this route table with your subnet, but before you do that you have to edit your routes and create a route for the internet. So remember, we called it a public route table, so this is where we route it from anywhere. So like the public internet is anywhere. We use the anywhere term to describe, like, this is any traffic coming from the internet gateway, and then the target is the internet gateway. So any traffic that comes from the internet has to hit the internet gateway, and this is what will direct it to our public subnet and now into our public server, which we haven't created yet. So make sure you click your AWS Cloud Internet Gateway and save the changes. So now your route table. So this is what is going to help you signify that this is the public cloud route table. You added a route to your internet gateway, and then now we also need to associate it to our public subnet. So this is now where you connect everything. So edit subnet associations and then click on the public subnet and then save the association. And then now this way our public subnet now has access to the internet. Look at our public subnet and look at the route table. It has access to the internet now. So you've set up a whole network. Now we want to set a public server inside this public subnet, which will be accessible by users from the internet. So now we create our EC2 instance, and let's click on launch an instance. Cloud instance, and then we'll use an Amazon Linux image for now. and then we can use a T2 micro just to save on cost instead of a T3. And then make sure you create a new key pair. So click here and then give it a name and create an RSA one. So if you're on Linux and Mac, use a .pem file. If you're on Windows, use a ppk file. So make sure you note that based on your computer. So I had created one, so I use a lab challenge 2, and then you also need to edit our network. So click on network, edit your VPC into the VPC that we want, and then make sure to change your subnet into the public subnet, the subnet that has internet. If you forget to adjust this, then you'll be able to access people won't be able to access your server. So also enable auto assign public IP so that when we create something inside the server, we can use the public IP and just view it on our browser. So you're also going to create a security group and call this AWS Cloud OKU, and this is allow developers, and SSH and users HTTP. So remember, we're only saying allow developers, not everybody. So in this case, I'm going to use my personal IP to get this. So just click on my IP, and to get this IP, the website called whatismyip.com, which it will give you the public IP of wherever you are, and then when you come to select it here, it will give you a CADR option, and then you just click on it. So yeah, make sure your IP is the IP that you get from this website. And then you can add a security group as well for, remember we said SSH for developers and users HTTP. Let me just use HTTP for now. So HTTP, HTTP, and then remember HTTP is for all users, so this is going to come from anywhere on the public internet. So yeah, I think our security group is done. And then the last thing that we're going to do is we're going to create something called user data, which is going to be found down here. So when you want your server to launch with pre-packaged stuff, so you can package your server if you want a particular server, or if you want any particular thing, anything installed inside your instance, you can just use this user data. So we're going to use a script that I had created for this. Just give me one sec to find it. Where did I put that script? One sec. I had that script somewhere. Or did I change my user? Yes, found it. So this is simply a bash script that is going to use DNF, which is like a newer version of how to install packages on Amazon Linux OSs, and then we're going to update it, and then we're going to install an Apache server, and then we're going to start it. So start the server and ensure it runs on boot using systemctl, and then define the root directory, which is like now we are going to place your files, and then we'll have a simple index file that says hello from Amazon Linux, and yeah, that's basically it. So this is what the web page that you're going to see. So yeah, once I have that in there, and just confirm our network is okay. Yeah, so we can launch our instance. So we'll wait for it to finish initializing. But as you can see, we got a public address, and we also have a public DNS somewhere here. It hasn't finished yet, but we also should get a public DNS. So once it's ready, we need to test how if we can connect to it through SSH, and also if our web page is visible to all users. I'm just going to see if this is done. I believe we should change this. So remember, we only put port 80, which is HTTP. HTTPS is port 443, so this will not work. We need to put HTTP, and as you can see, Amazon Linux provision successfully. DNF, Apache, and user task script worked on Monday 11:52 UTC, and so this is like 3 hours for me, I guess, but it was 2 minutes ago. So it means that HTTP is working correctly. So we should also test HTTP and SSH as well. So come into SSH client, and if you did everything correctly, you should be able to connect to your instance using this. So make sure you're in the directory that your PEM file is in. So in my case, I believe it's here. Then I'm going to /i the large PEM file, and then the user, which is EC2 user, and at the IP address, which is this. Then you want to connect, say yes, and then boom, we are connected to the instance. So this is like basically it, and if you have questions, just reach out to me on WhatsApp or Discord. Have a lovely evening.